everyone. IEEE Women in Engineering VIT presents you the essay playlist. And today's topic is Q. And about me, I am Priyanka Kumari. So yeah, let's get started and discuss about Q. So basically, Q is a linear data structure which follows a rule which is known as first in, first out, which means the element which comes first will be deleted first. So basically, what happens is the element which is at the front of the queue will be deleted always first and then only the rest of it. And always the insertion will take from the back, so the last element, after the last element only, a new element will be inserted in a queue. So basically this is what is FIFO. Then there are many variations of queue as well, which is a normal queue. Then it is a DQ, which is also known as doubly ended queue, priority queue, doubly ended priority queue. So these are the some of the variations of queue. Let us look at the operations of queue. So basically queue has many operations, which is enqueue. So for enqueue we have to pass a parameter, which is the element which we want to insert. Basically enqueue is a normal insertion and it has a special name as enqueue in queue data structure. DQ, as you can suggest, that it is also a deletion operation which has a special name in queue as DQ. Get front. So basically what get front does is get front gives you the first element, the element which is always at the, which is the first element of the queue. It will be given by the get front operation. Get rear. Rear is basically, you as you know, it is the last element of the queue. So get rear always returns the last element of queue. Size. So this operation returns the number of elements which are present in the queue. Is empty off. So is empty checks that whether a queue is empty or not, that whether it contains any elements or not. Similarly, we have is full also, which checks that whether the queue has reached its maximum capacity or not, that is, can we insert any other element or not. So enqueue, which is store an element in the queue. Dequeue, it removes an item from the queue. Peek off, it gives the element at the front of the queue without removing it. So basically peek will give you the first element which is present, which is the front element of the queue, without removing it. It won't get removed. Is full checks that whether the queue is full, and is empty checks that whether the queue is empty or not. Let's understand the working of the queue. So basically, the first value, which is the first element in the queue, it is the front end from where the deletion takes place, and the deletion is also known as DQ. So always the deletion will take from here, from this end, the front end. Always the insertion takes place from the rear end, which is the last element of the queue, and this operation insertion is known as enqueue. So you can consider it as people standing in a ticket reservation center. The first person who reaches or who is standing in the line will get its ticket, and he or she will leave from the line or queue. So it is actually a implementation from real life. It can also be used in OS for FCFS, which is first come first serve, where the processes are waiting for a particular resources and it would be served first, which is stored in the queue. The process which is stored in the queue first will be always served first. So yeah, then let us see the enqueue operation. So for the enqueue operation, we check that whether the queue is full or not. If the queue is full, then it is not possible to insert any other element in the queue, and so it is not possible that operation. So we simply return. We produce an error which is known as overflow error, and we exit. If the queue is not full, then we increment the rear pointer, which is the last element. The pointer, it would be incremented to +1, and at that point a new element can be inserted, and we return the success. Similarly, a DQ operation, it checks first that whether the queue is empty or not. Obviously, if the queue is empty, we can't delete any element. And if it is empty, then we produce a special message which is a underflow condition, and it is underflow error, and we exit. If the queue is not empty, then we access the data where front is pointing. So always the element which is present at the front will be deleted, which is the first element of the queue, and then we return success. So after that, we'll see the implementation of queue. So it is basically the implementation of the queue using array. So it is basically implementation of queue using array. So in array also we have two ways to implement queue, which is a simple implementation which takes O of 1 time for insertion but O of n time for deletion. So we use a special array which is known as circular array for this thing. So let us see the implementation. First we declare a class which is queue, and we insert some variables, which is front, which points to the first element of the queue, the rear, which points to the last element of the queue, and size, which denotes the number of elements which are present in the queue. Then there is another variable which is capacity, which is the maximum capacity of the queue. Then we declare a array, and then we make a new queue, which is we create a queue using this. We actually assign the queue capacity as capacity and queue front, and also the queue size will be initialized to 0, because now the the queue does not have any elements. Then we initialize the rear as capacity minus 1, and then we return the queue. Then we check the operation, we perform the operation is full. Then it checks whether the queue has reached its maximum capacity or not. Is empty, it checks that whether the queue size is equal to 0 or not. So this is implemented using the function is empty, and this is implemented using is full. Then Enqueue operation, which is insertion. So for this, using circular array, we first increment the rear as queue of rear plus 1 modulo capacity. If we do this, we'll be getting the new rear, which will always be the element which is at the last of the queue. After that, we insert there the new item which the user want to insert, and as we are inserting any element, then the size will get incremented by 1. That's why we do size plus 1. And then we simply print out the message that the particular item which the user wants has been enqueued to the queue. The dequeue operation, it was first if the queue is empty, then it will simply return int min, and if it is not empty, then it would be doing front plus 1 modulo capacity, and the size will be decremented by minus 1, and then we return the item. Int front, it gives the first element of the queue, which is given over here, and int rear gives you the last element of the queue, which is basically given using the syntax. And then there is int main function from where we are initializing or calling the operation, which is enqueue. So here now the queue will have element as 10, then the queue, as we are enqueuing or inserting 10, so it would be initialized or enqueued after 10, so it will be now 10 20, then it would be 10 20, and then 30, and after that we are enqueuing, so it would be 10 20 30 and 40. So simply then we are doing that, we dequeue the queue. So now dequeuing will be happening. So now the element which is present at the first will be deleted. So now the array or the queue will be having 20 30 40 only. Then if we want to print the front item, which gives the front item, it would print us 20, and the rear, which is the last element, it would be 40. So this would be printed, and if I run this, you can check, yeah, so we got the same thing, front item as 20, rear item as 40, and then 30 40 10. 10 is dequeued from the array which I told, which I dequeued, and then after that 10 20 30 40 are enqueued in first. Yeah, so now let us look at the linked list implementation. We can also implement the queue using linked list. For this, we create a special structure queue node and we initialize the node, or we make a simple node. After that, we create a structure queue, and in this we are again initializing front and rear, and at first both front and rear will be null as the queue is empty. And for enqueuing, what we do that we create a variable called temp, and we initialize new node. We create a new node and insert the element x. Then we check that if the rear is equal to null, then front and rear both will be equal to temp. So because already the queue is empty, so it would be the first element which we are inserting, so both will be pointing to the temp itself. Then we are incrementing the temp using a new node, and which is rear of next will be equal to temp, and then the rear will be initialized to temp. After that, DQ operation is performed, and for DQ again we check that if front is equal to null, we return. And again we, using the new node implementation of linked list, we insert a new temp variable to front, and front will be initialized to front of next. If we do this, obviously the front element, as we are moving to the next node, the first node will get detached and it would be removed. And if front is equal to null, means it is the last element which we are deleting, then always the rear should also be equal to null. And then we perform the delete of temp, that is we clear the memory. So here again it would be the queue would be 10, again here it would be 10 20. As we are dequeuing, now it would be, now the 10 would be deleted, so we'll be having 20. This would be empty. Then if we enqueue, then it would be 30, then it would be 30 40, 30 40, then this would be 30 40 50, 30 40 50. And if we dequeue it, then again we'll be having 40 50 itself, because the 30 would be deleted. Now if we want to print, we'll be getting queue of front as 40 and queue of rear, which is the last element, as 50. So same would be returning over here, which is, yeah, 40 and 50. So yeah, that was all. Hope you liked the presentation. Thank you.